before that, we had also YOLO. My background has been in, like, I've been building AI broadcasting camera, and we knew pretty well YOLO model. But specifically for some reason, like for interior design and home decor, we had a lot of struggle. We've been trying out different models with YOLO, but then, the detection part, and I'm not even talking about segmentation, they were terrible. So basically we went with Florence, and we had pretty good results in terms of like performance, like detection performance. But we had issues like on the speed. So when we were running, basically we had 10 seconds of the object detection part, but then we've been obviously basically did PyTorch compile and improved our GPUs, and that was reduced to 1.8 seconds. And why I'm saying these numbers are critical, because I'll be showing you a demo how it works in production with our customer, because like we have multiple stuff. We have image generation model, object detection, segmentation, we have recommendation part. And all of these are taken some minutes actually to build and basically run. And from this perspective, every second is crucial for the customer experience. And actually recently, we've been running with the YOLO game. We've been doing some experimentations, and this time YOLO was amazing. We don't have it in production yet, so you will still see the model, the older model. But the amazing thing was that even without optimization, when we first run, we could actually run it for 30 milliseconds. So you can see the improvement from 1.8 to 30 milliseconds. But what we've done is that basically we were having it in TensorFlow, but then we exported and then compiled on the TensorRT model, and we reduced to 4 milliseconds. So in our next iteration, when we will go into the next production, it will be extremely fast, but not just that, also the performance in terms of like the recommendations, that will be improved. So we had, from there, basically we had embedding model, we had 1268 dimensions with VIT, Vision Transformers, that goes to quadrant, which is vector database, and we are doing basically cause and similarity there, and then recommendations you can see for this cognitive. So I would like to show you now one of the demos of that. This is not from customer, it's more like what we've been doing recently, one of the experiences. So basically you take a picture, what we have is that it's processing the image, and then basically we have detections, here are pillows, the couch, and then you will see also the recommendations of the sofas, of the pillows, etc. I would like to give one, basically, the demo from our customer. This is our customer Vivre. They are the largest furniture marketplace in Romania and Central and Eastern Europe. So here I'm gonna take some of the images. So then we run basically, let's say, one of these objects, items, and then what happens is that it will find similar items from the Vivre catalog. I'll show you some of the examples. So you can see here, basically, the similarities that we usually see. But what I'm saying is that it's actually faster than that on our side. And then let's go deeper into a bit of architecture. So basically, that was our synchronous architecture. I don't have much time, so I'll go quickly. So we've been using OpenSearch here, and it was sequential, so it was a bit slow and then not really scalable. But we've done it because it was fast. So that was our first iteration of the production. But OpenSearch is a bit slow, and also at scale is not the best solution. And then we started looking for more solutions for vector database. There are lots of them, Millboost and Pinecone, etc. The best one, and this is our current pipeline. So here what you see is that so it's async architecture, and we have every instance is actually independent from that perspective. So we have the essential thing is that we have metadata that we have from the products, from SKUs, and then image, queue are separate. We use our own product image processors to index all of that data, which we store in PubSub, in GCP, and then goes back to Quadrant to basically do cause and similarity. And just to show more examples on the Vivre side, so the speed. So here, it's basically some of the examples of what their customers are doing. They upload their image. We do an image generation model, and then we find the items here, like that you see on the picture, similar ones. Obviously, like this is AI-generated image, so it's not really in the real one, but you can see that it finds very similar items. And there are lots of examples. As I mentioned, it's also zero shots. It's not necessarily for furniture, but we particularly focus on furniture. And then this is another example. And then we can, for example, I can show you also the objects here as well. And then we find not just like furniture, as I mentioned, like also house plants, some other items as well. So then, for example, this is another example. This will provide their customer, their kitchen, and then we again give them shop book. And then if you go like to, for example, like specific item, and then it finds similar items. Another thing is that once we do in vector database, we also cache hot neighborhoods so that when the user clicks on the same item or we do shop the look, it's basically much faster. And then this is another example of the bedroom. Previously, it will be finding similar items from this. Let's go, like for example, in this case, cabinetry as well, and then you can find and basically purchase. So you can see it's basically in production, and then you can like it, buy it, etc. If you're based in one of these Central European countries, they don't deliver to Germany, unfortunately. I think I covered the majority of the items. If someone is in e-commerce marketplace, please contact me. You have my email there. And if someone in general is interested, let me know as well. Thank you.
Why use YOLO rather than something that gives it the outline or put a bounding box rather than really the proposal that fits the shape of the item?
So we do not just bounding box, also segmentation, as I mentioned. It gives better similarity score. If you focus on a particular item, when you index it and then run in vector database, it gives much better similarity score on the catalog that we have in e-commerce.
The segmentation is a step in your pipeline.
Yes, I mentioned that.
Yeah, I'm curious why. This is our question.
But that's what I'm saying. We crop it out with the segmentation. The area of the item.
Yeah, it's a bit like using YOLO for the rough region proposal and narrowing it down and trying to understand why not go directly to some more precise region proposal.
One question about you were showing some numbers and about how much improved the response time. Which kind of GPU were you using, or you were evaluating different kind of grade of GPU and you see huge improvement within the cheapest one and the expensive one?
Yeah. So obviously we do that. I can't tell exact the models of the GPUs, but so it depends on the stuff that we are doing. So for example, for the YOLO one, we haven't been doing more powerful GPU, but its performance was better than in Florence case. In this, obviously, when we started with Florence, we started with the with the less powerful GPU, and then switched to more powerful. It improved the performance. But for example, for YOLO, we are using for the YOLO we are using the same GPU. We haven't switched to the more powerful one, but the performance is still much better. There could be, maybe we can try as well, we switch to TensorRT. Maybe in Florence we use PyTorch. Yeah. So maybe if we switch, that's another experimentation. Maybe we will do that to see, but we were happy with the results that we see so far. Yeah.
How sensitive is the matching towards the viewpoint? Let's say I take a photo of this chair from the back because I like the back design.
Yeah.
Is it going to be able to find the product from a different angle because the shop has a different product angle, something like that?
Yeah, that happens. Actually, we have the issues, for example, when we're searching for some chairs, but the first picture is not chair. It shows overall set. And that is something that we are still working because we'll be adding additional filtering for each customer. And another thing is that in the architecture that I mentioned, it's we build multi-tenant architecture. So for each customer, we'll have different approach when it comes to re-ranking part, re-ranking algorithms, and also filtration as well, additional filtrations that is specific for their needs. Because it could be that we work with furniture companies, but it could be that we will be working with fashion industry, and then their needs will be a bit different.
So probably for your customers, it's a good idea to index product photos taken from different angles, because just in case, like,
Yeah, that's
consumers
another-
can't
yeah.
take photo from any angle, right? Yeah.
That's true.
Mhm.
Actually, like with the image generation, we've done that. Like for example, like we see that customers sometimes take a picture and they just take a picture of the angle,
Right.
and then it's not like, what are you gonna do with that? And then we like kind of move away the camera and that basically give better design. Maybe it's not that realistic, but it's nice.
All right. Thank you.